graphing y for sine x, cosine x, and tangent x. As you recall from our previous lesson, we have the unit circle, which can be looked at in multiple ways. We can look at the coordinates of the xy axis where each component falls on the circle based from the origin. And we've got, for example, at 0 degrees, or at a very flat line, 1, 0, 90 degrees, 0, 1, minus 1, 180 degrees, minus 1, 0, and then 270 degrees, 0, negative 1. Now, we can also coordinate this, again, by looking at the coordinates. For example, at 45 degrees, the coordinate is the x, is cosine. The sine is the y coordinate. So the distance from the center to that point of the circle horizontally is the square root of 2 over 2, right here. And then this distance right here, from left to right. And then the distance from the origin vertically is the y-axis. Remember, this is also the sine, and this is the cosine. And we get where our distance is right here, the hypotenuse, which is always 1, based on the unit circle. That angle is always based from the origin. So we can look at the coordinates, where it is for x-axis and y-axis. We can also look at radians in terms of pi's. In other words, it's the radius is 1, 2 pi times radius is circumference. So 2 pi times 1 is 2 pi. So the entire way around is 2 pi, as we talked about. And if we go halfway around from 1, 0 to negative 1, 0, that's pi. Quarter way around, half of that would be pi over 2. So we've already discussed this. Now I want to go to the next page, and I want to narrow this information down, because we're not going to look at the quadrants right now. We're going to look at just looking at the xy coordinates and the radians. So this is our same circle, same information, but all I have is in the x in the first column, radians, and then the equivalent of the location of it in xy coordinates. In other words, 0 pi, which is right here, is the same as 1, 0. 0 pi, 1, 0. And if I look at 45 degrees, that is also right here, 45 degrees, which is pi over 4, which has x coordinate squared at root 2 over 2, and a y coordinate squared at 2 over 2. Here's my pi over 4, and there's square root of 2 over 2, square root of 2 over 2 for the x and y coordinate, which is, again, the cosine and sine. That's all I've done is just cleaned up this table a little bit. Now what I'm doing here is I'm going to create a specialized graph, which is called a sine wave or cosine wave, depending on what we're looking at. And instead of on the x-axis, instead of 1s and 0s, I'm going to do it in pi's. So this is, instead of 1, 2, 3, 4, what I'm going to do is I'm going to create it in radians. And in fact, here's pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, there's pi. And then we keep following those pi's until we get to 2 pi. And this is an entire period here. Because if we look at this, here's 0, here's 2 pi, and it starts back over. Here's 0, and again, that's 2 pi. So it's a repeat of itself. So we're going to look at this area from 0 to 2 pi. And if I graph this by the height, I've got a distance here, and this is 1. The vertical is 1. This is 1/2. the y-axis. This is negative 1/2. You can see the negative 0.5 down there. And here's negative 1. You can see it's real tiny. But I'm making a point here. I graph this. My x-axis right here where it starts at 0 pi is also, I'm looking at my sine, which is 0. So 0, 0. Now let's look at the sine for, I'm going to take the sine here. The sine is always the y. Here's 1. And what pi is this? This is pi over 2. I got an arrow pointing right here. Here's pi over 2. Then I have to go halfway across. Here's pi. Here's my pi. And again, the sine is 0. If I go to 3 pi over 2, which is right here, and right here, it is at my y-axis, my y-coordinate, which is my sine, is negative 1. And then it starts all over here. And I can look at every coordinate on here. And when I go around the circle here, I create this graph. And it starts all over because they're starting with the circle all over again. The best way to think about this is actually spinning around the center here. Where our circle here we're looking at is looking at straight on towards you. And then this is straight on. I'm going to put straight on SO, looking at you. Try to draw some eyes here. They're looking right at you. And then this is the same view if someone was looking sideways, looking out in that direction. So it's spinning around a circle. But from the side view, if it's spinning and moving forward, it creates this wave motion. With cosine, we have the same similar response. We still have our x-axis is now written in radians, as you can see here. Here is 2 pi right here. Here is 0. And if we look at, for the cosine, we remember is the x component. It's very similar to the sine. There's a slight shift. When we have 0 pi right here, this is right here, start here. And then on the vertical axis for the cosine, it's 1. If we're going to look at pi over 2, right here, and right here, our cosine, which is again our x-axis, is at 0. And then if I go back down to my pi, which is halfway around the circle here, from here to here, here's pi, and my cosine is negative 1, which is right here. Then 3 pi over 2, my cosine is 0, here's 3 pi over 2, and here's 3 pi over 2. And my cosine, which is my x, is 0 here. And then it starts again at 1, 0, 2 pi or 0. It starts all over again. Here is 2 pi, and which is 0 pi. So starting over. And again, it's 1 for the cosine, which is the x-axis, which is right here, the 1 component. Tangent is rather interesting because remember, tangent is sine over cosine. So tangent of x is sine x over cosine x, which would be, in this case, if you look at this, we got sine x cosine x, and I'm going to 0 pi here. My pen going, sorry about that. Here is 0. And this would be my 0 pi right here. And notice it's sine x over cosine x, which in this case is 1 over 0. So it's 0, 0. And then if we go all the way to pi over 2, it's interesting. Here's pi over 2. Here's pi over 2. Well, the problem is remember, tangent x is sine x over cosine x, which in this case would be 1 over 0. And that is why we have a vertical asymptote. And if you go to negative pi over 2, which is the same as 3 pi over 2 backwards, right here, that would be negative 1 over 0. And again, when you have a 0 in the denominator, it cannot exist. Hence, we have a vertical asymptote here and a vertical asymptote here. And basically, our tangents one graph can only go from negative pi over 2 to pi over 2. That's also known as 3 pi over 2, because we got zeros in the denominator, which is our cosines.